here's question is asking, design the circuit figure P7.98 so that the transistor operates in a saturation with VD biased 1 voltage from the edge of the triode region. ID is equal to 1 milliampere, VD is equal to 3 voltage for each of the following two devices. Use a 10 microampere current in the voltage divider. And also we have these two, like we have A part and B part. A part I did in my previous video. So in this video I'm just going to do the B part here. I'm just going to solve the B part. A part, if you want to know the A part, you can watch my previous video, I already posted. Okay, let's look at the given information. We have to find all these values. We have to find our VG, VD, VS, R1, R2, RS, RD. And let's solve the information provided to us. We have ID, that is 1 milliampere, and then we have VD, that is 3 voltage, and then we have VT, that is 2 voltage, and we have Kp prime W over L, that is 1.25 milliampere per voltage square. So we have all this information. The one that is straightforward is RD, because we have ID and VD available. So V is equal to I times R. So R is going to be V over I. VD divided by ID. And we already know the VD, that is 3 voltage. Also we have the ID, that is 1 milliampere. So this one becomes 3 kilo ohm resistance. Okay, so we have done this part. The next one we can do is we can use the saturation current equation. The current equation in the saturation mode is given by ID is equal to ID is equal to Kp prime half Kp prime W over L VG VS VSG minus V threshold whole square. So let's plug all the value known. We know the ID, that is here 1 milliampere, and we know the Kp prime W over L, that is provided here, that is 1.25 milliampere per voltage square. And we don't know the VSG, but we know the V threshold. For the B part, the V threshold given to be 2 voltage. So plug that in, square, and then here we don't have to worry about the unit because milli cancels. So others are in the SI unit already. And if we rearrange this one in terms of VSG minus 2 square, VSG minus 2 whole square, if we remind this one in the one side, and the other side if we bring this 2 to the half to the other side, that's going to be a 2, and then 1.25 will be dividing, and that is it. So 2 divided by 1.25. And that one comes out to be 1.6. So if we take VSG minus 2, then here we have square, so we have to square root both sides. So this square, if you square root this square root go away, and here we will have square root. Therefore VSG is going to be the value after square root plus this 2. The value after square root is 1.265. If you add 2 to that, that is 3.265 voltage. Okay, that is VSG, but that is not the one asked. We want to know VS and VG separately. VSG is basically VS minus VG. If we know one of them, we can solve the other using this. So we don't know both of them, so we had to do something else. So let's keep this one as it is for now. And another voltage for VDS, that is drain source voltage, that is given by gate source voltage minus V threshold minus 1. Okay, here we have source gate voltage, that is 3.265. So gate source voltage is going to be opposite, like we just switch the VSG to be VHGS. So that's the difference is going to be minus when you switch. So here we switch this one, so that's minus here, and then 3.265, and then V threshold here is 2 voltage, and that's going to be negative. So minus 2 and then minus 1. So minus 3.625 minus minus 2, that's plus 2. Plus 2, then this is going to be minus 1.265. Minus 1.265 plus minus 1, that is minus 2.265 voltage. So VDS is there. VDS is basically VD minus VS. And we already know the VD right here, that is 3 voltage. So we can solve for S here. VD minus VS is equal to minus 2.265 voltage, and we know the VD to be 3 voltage, so put that one right here, and then minus VS is minus 2.265. Therefore if we solve for VS, that is 3 plus this, so that's going to be 5.265 voltage. Okay, now we have the VS, that is one of the required one that is asked here, so we solve this one. Okay, and also I think we also saw the VD. Did we? Yeah, VD is already there. VD is the one already there, so that one is not necessary because that's already given. So VD is already there, and VDS we solve for S, and then VSG. Since we know VS, we can find the G because VSG is basically VS minus VG. So let's put that one right here. VSG is given to be 3.625 voltage, and VSG is basically VS minus VG, that is 3.625 voltage, and VS we know that 5.265 voltage minus VG, and that is 3.625. Wait a minute, 3.625 or 265. Okay, so VG comes out to be 2 voltage. Okay, now we solve this one. So that is one of the needed part here. Now we just left with the resistors to be found. We have to find out R1, R2 and RS. To find the R1 and R2, we can do one thing. We can use the voltage divider, and also they have mentioned that 1 microampere current passing through the voltage divider. So it means that if you use KVL here, that is minus 10 plus, let me use a different color. Okay, minus 10 plus the voltage across this resistor, and this resistor should be equal to 0, and the current passing through this is 10 microampere. So this one plus 10 microampere times the R1 plus 10 microamperes times the R2 should be equal to 0. Therefore 10 plus, here we can take the 10 microampere common, and that one gives us 10 microampere times R1 plus R2, that is equal to 0. Therefore R1 plus R2 is going to be 10 divided by 10 microampere, and that one gives us 1 mega ohm resistance. Okay, that is R1 plus R2, but we want to find out R1 and R2 separately. but here also VG is there. We know the VG. We solve for the VG right here, so we can use the voltage divider right now. VG is equal to 2 voltage, and VG also equal to the voltage divider, that is 10 times whatever, like R2 over R1 plus R2, or you can find out R1 as well, whichever you want. So here if I plug the value for VG, that is 2, that is equal to 10 R2 divided by 1 mega ohm resistance, because R1 R2 we just found out over here, so I'm substituting that one for this. So 1 mega ohm, and this one becomes 0.2, and mega multiplies here, so R2 is 0.2 mega ohm. If R2 is 0.2 mega ohm, then R1 is going to be whatever left. Since R2 is 0.2, then R1 must be 0.8, because both of them together make 1 mega ohm. So this is 0.8 mega ohm. So we have now R1 resistance and R2 resistance. Okay, so this one is solved. R1, R2. The only thing that's left is RS. Alexa, stop. So the only thing that is left is RS. To find out the RS, we can apply KVL over here. If we apply KVL, KVL can be applied, you know, this one can be considered as a loop, this one considered as a loop, like it's like source, gate, and drain. Okay, you can consider each of them as separate loops. So this one is a loop, this one is a loop, this one is a loop. So here, if we consider this loop here, KVL, apply KVL, so this is going to be minus 10 plus, and then RS, the current passing through this one is the drain current, ID times RS, and then plus the VS should be equal to 0, and minus 10 ID RS. ID we already know, let's plug that one in here. ID is given in the question, that is to be 1 milliampere, so plug the one here, 1 milliampere. RS is what we are trying to find, and VS is already we found out somewhere here, that is 5.265. Okay, that is equal to 0. So rearrange the equation and solve for RS. So this is going to be 10 minus 10 plus 5.265, and that's going to be a negative value, but if you bring to the other side, that's going to turn into positive, and that one divided by milli becomes a kilo. So if you solve with this one, you will end up getting 4.735 kilo ohm resistance. Okay, and that is the final one. That is the last one we needed to find, and we found that one. And that is it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.